You have eaten umami thousands of times. You have craved it without knowing what to call it. You have gone back to a dish for a second helping and told yourself it was the seasoning, or the heat, or the quality of the ingredients, when actually it was something older than all of those explanations. Here is the part most people do not realize. Humans have been tasting umami for as long as we have been cooking. But until 1908, barely 100 years ago, no one on Earth had a word for it. No scientist had isolated it. No culture had named it as a distinct sensation. The 5 tastes that define how your tongue works? 4 of them were named in ancient Greece. The 5th took until the 20th century. 1 man, 1 bowl of soup, 1 laboratory in Tokyo. This is the dish files. Somewhere in your education, a biology class, a cooking show, a food magazine, someone told you that human beings detect 4 basic tastes: sweet, salty, sour, bitter. The framework is ancient. Aristotle wrote about taste in classical Greece, anchoring his system around sweet and bitter as the 2 foundational poles. The Ayurvedic tradition in India catalogued 6 tastes, adding pungent and astringent to the mix. European science eventually consolidated the model down to 4: sweet, salty, sour, bitter, and for the better part of 2 millennia, that number held. 4 was the answer. 4 was complete. The problem was that the answer was incomplete. Any serious cook working in any serious kitchen at any point in recorded culinary history had encountered something that did not cleanly fit those 4 categories. Ripe tomatoes do not taste sweet, not exactly. A long-simmered meat broth does not taste salty, not exactly. Aged Parmesan cheese has a depth that the word savory comes close to but does not capture. There was a sensation that was real, that was reproducible, that every palate recognized, and there was no name for it, no mechanism, no science, just the thing itself, sitting at the edge of language. The Japanese had a phrase they reached for in cooking, a dish that made you want to eat more, a flavor that made you lean in. They called it umami, delicious. The word was there. The science was not. In the spring of 1907, a chemistry professor at Tokyo Imperial University sat down to dinner at home. His name was Kikunae Ikeda. He was 43 years old, trained in physical chemistry, recently returned from 2 years of study in Leipzig under the German chemist Wilhelm Ostwald. He was, by training and temperament, the kind of person who asked why. The soup in front of him was dashi, a Japanese stock made from kombu, a type of dried kelp, and water. It is one of the oldest preparations in Japanese cooking. Clean, pale, deeply flavored in a way that is difficult to describe. Ikeda ate it, and then he did what chemists do. He asked a precise question. The question was not, "Why does this taste good?" That is a question for poets. The question was, what is the substance responsible for this taste? He went back to his laboratory and spent months isolating the key compound in kombu. He worked through the chemistry of the seaweed systematically, extracting, purifying, testing. From 12 kilograms of kombu, he ultimately recovered about 30 grams of pure L-glutamic acid. The same compound, in its salt form, is monosodium glutamate. Ikeda had not invented a flavor. He had identified one that had always existed. The glutamate is in the kombu. It was in the kombu before his experiment, before his laboratory, before modern chemistry. He had simply given it a name. He called it umami, from umai, delicious, and mi, taste, the pleasant, savory taste. Or, in the most direct translation, simply deliciousness. In 1908, Ikeda published his findings in the Journal of the Tokyo Chemical Society. He named a new category of taste. He also patented a method for producing MSG, monosodium glutamate, as a commercial flavor enhancer. The discovery and the commercial product were separate things. That distinction matters because for most of the next century, the world conflated them. When Ikeda published his paper, he was not just proposing a new culinary category, he was making a claim about human biology. If umami is a basic taste, not a combination of the 4, not an after effect, not a cultural preference, then there must be specific taste receptors on the tongue that respond to it. The same way sweet receptors respond to sugar, bitter receptors to alkaloids. A physiological mechanism. The reason this matters goes back further than 1908. Evolution does not give us tools we do not need. Every basic taste corresponds to a biological function. Sweet signals carbohydrates, energy. Salt signals minerals. Sour signals fermentation or spoilage, warning. Bitter signals potential toxins, warning. So what does umami signal? Protein. Specifically, the glutamate that is released when protein breaks down. Humans are protein dependent. Our muscles, enzymes, immune systems, and neurotransmitters are built from amino acids. A tongue that could identify high-protein foods and that coded them as rewarding would have a survival advantage. The animal that craved meat and fermented foods would eat more of them and live longer. Umami is, in the most literal evolutionary sense, the taste of protein availability. Your tongue learned to recognize it millions of years before Kikunae Ikeda gave it a name. The primary umami compound, glutamate, is found in foods that humans have considered delicacies across almost every culture: aged cheeses, cured meats, ripe tomatoes, mushrooms, soy sauce, fish sauce, miso, anchovies, shellfish, Worcestershire sauce. Every culture that learned to ferment or age food was concentrating glutamate. They were engineering umami without a theory to explain it. Ikeda published in 1908. The next 80 years of Western food science largely ignored him. Not because his chemistry was wrong, it was not wrong. Not because umami could not be tasted, it could be. The reasons were institutional, cultural, and in some cases commercial. What it took to finally break that silence is its own story. First, science resists new categories. The four-taste model was embedded in textbooks, in curricula, in the research frameworks of sensory biology. Proposing a fifth taste meant challenging an established paradigm, which meant peer resistance, which meant slow adoption. Second, the language barrier. Ikeda published in Japanese. Translation was not immediate. The scientific community most capable of evaluating his claim, European and American sensory physiologists, did not read his primary work for decades. Third, MSG. When Ikeda patented monosodium glutamate as a commercial additive, the substance entered the food industry on a massive scale. By the 1960s and 1970s, MSG was in processed foods across the United States and Europe. Then came the controversy, unfounded, as the science would eventually show, but loud and lasting. Chinese restaurant syndrome. A supposed connection to headaches and nausea that multiple controlled studies failed to reproduce. The name of the compound that proved umami's existence became culturally toxic. The baby got thrown out with the bathwater. Arguing that umami was a legitimate taste required arguing that MSG was misrepresented, and that was a fight most researchers chose not to pick. So for most of the 20th century, umami sat in a kind of scientific limbo. Observable, reproducible, present in every great cuisine on Earth, and officially unnamed. In 1985, 77 years after Ikeda published his paper, a group of scientists gathered on the island of Kauai in Hawaii for the first Umami International Symposium. It was a modest event, but it was the first time umami had been formally presented to an international scientific audience as a candidate for fifth basic taste. Researchers from Japan, the United States, and Europe presented psychophysical and biochemical evidence. They demonstrated that glutamate elicited a distinct sensory response that could not be explained as a combination of the four accepted tastes. The symposium did not produce an immediate consensus. Science does not work by symposium vote, but it opened the formal conversation in the Western scientific literature. The next decade and a half produced the evidence that closed the case. By the late 1990s, electrophysiological studies had demonstrated distinct nerve responses to glutamate. Biochemical research had identified specific taste receptor cells that bind glutamate. In 2002, 94 years after Ikeda's original publication, researchers at the University of California, San Diego identified the specific receptor protein responsible for umami taste, the T1R1-T1R3 heterodimer, a receptor that exists specifically and exclusively to detect glutamate. The science was settled. Umami is the fifth basic taste. It has a receptor. It has a mechanism. It has been waiting for its name since the first human cooked over a fire. Here is the part of the umami story that most explainers skip, because it is where the science gets genuinely strange. Glutamate is the primary umami compound, the one Ikeda isolated, but there are others. 5-inosinate, found in meat and fish. 5-guanylate, found in dried mushrooms. Separately, each of these compounds produces a detectable umami sensation. But when you combine glutamate with either of the nucleotides, inosinate or guanylate, something unexpected happens. The umami perception does not add up. It multiplies. Decades of human sensory research, most clearly documented in the work of Shizuko Yamaguchi in the 1990s and confirmed in later review papers, found that combining glutamate with inosinate can amplify umami perception in human tasters by up to 8 times. Not 8%, 8 times, 800%. The mechanism is thought to involve receptor synergy, the two compounds binding to different sites on the taste receptor simultaneously, producing a response far greater than either alone. The technical term is umami synergy. This explains something that great cooks have known empirically for centuries without a theoretical framework to support it. Ramen broth. Kombu, which is glutamate, plus katsuobushi, dried bonito, which is inosinate. Bolognese. Tomato, which is glutamate, and ground beef, which is inosinate. Worcestershire sauce. Anchovies, tamarind, and mushroom extract. The cooks who built these preparations were engineering an 8 times multiplier without knowing the arithmetic. And this is the part that connects to Thursday. When you cook beef with mushrooms and finish the dish with cream and Parmesan, you are combining 3 distinct umami sources: inosinic acid from the beef, guanylic acid from the mushrooms, and glutamic acid from the cheese and cream. You are not just seasoning a dish. You are triggering a synergy that multiplies the perceived savoriness in ways no single ingredient can achieve alone. That is not a coincidence in a recipe. That is a deliberate stack. Once you understand umami synergy, you start reading recipes differently. Every cuisine that developed fermentation-stacked umami sources. Italian cooking builds on Parmesan, anchovies, tomatoes, and cured meats, all glutamate-dense, all layered. Thai cooking stacks fish sauce with dried shrimp paste with fresh aromatics, nucleotides and glutamates in every spoonful. Miso soup is glutamate from miso, plus inosinate from dashi, plus guanylate from dried mushrooms. These combinations were not designed in a laboratory. They evolved over centuries of iteration, of tasting, adjusting, and passing down the versions that worked. The science came after. The result was always in the food. The 8 times multiplier is why professional kitchens reach for anchovy paste in braising liquid, Parmesan rinds in broth, soy sauce in burger seasoning. It is why a recipe that looks simple, say, a cream sauce over beef with mushrooms, produces something disproportionately deep and satisfying. The simplicity on the plate is the product of a chemical reaction you can feel before you can name. Kikunae Ikeda sat down to a bowl of dashi in 1908 and began the chain of reasoning that eventually explains this. The kombu in his bowl was concentrated glutamate. The dish worked because of umami. He went looking for the compound and found it. The rest is a century of delayed acknowledgement, commercial confusion, and then, slowly, scientific vindication. The fifth taste was always there. You now know something that most people who cook do not know. Not the word umami has been in food media for a decade. But the mechanism, why it multiplies, what sources trigger it, why certain ingredient combinations produce something greater than the sum of their parts. That knowledge does not change what you eat. It changes how you think about what you eat. Next time you taste something that makes you lean in, That makes you want another bite before the first one is finished. You are not experiencing good luck or good instincts. You are experiencing a biological response that evolved over millions of years, named by a chemist in 1908, and ignored for most of the century that followed. His name was Kikunae Ikeda. His soup was kombu dashi. His question was, "What is this?" The answer took until 2002 to arrive in full, but every cook who ever layered mushrooms and aged cheese and cured meat into a single dish was already living in the answer. If you want to experience it, deliberately with the science in mind, stay until Thursday. We will walk you through a dish that stacks 3 umami sources in a single pan, and you will taste exactly why the theory holds. This is The Dish Files. I am glad you are here. Thank you so much for staying with us until the end. If you enjoyed this video, don't forget to subscribe to the channel and join us for the next one.